Hello, my name is Matthew Ferreira, and this is Lab 2, Charge Tapes Revisited. The purpose of this lab is to produce a computational model of two charged tapes exerting an electric force on each other. The charge on each piece of tape must be distributed evenly along the length of the tape, which differs from the Lab 1 model of concentrating the electric force onto a single point charge. In this lab, we only really use glow script. The rest of the actual experimentation is done from the Lab 1 procedure. And just to give you a preview of the results, the point charge from Lab 1 was about 2.5 e to the negative 9 coulombs. Meanwhile, for this experiment, the line of charges charge was 3.3 e to the negative 8 coulombs. Here are the fundamental principles for this lab. So we have Coulomb's law, which describes the force between two charged objects. We see the equation written here. We have the law of universal gravitation, which states that objects are attracted to each other with a force that is directly proportional to its mass and inversely proportional to its distance apart. And then Newton's second law, which states that the force acting on an object is equal to the mass of that object multiplied by the acceleration of that object. So here's some important details carrying on from Lab 1, since this is a continuation of this lab. So our main system was the top tape A, which is represented by this red ball on our glow script model on the right. The surroundings were the bottom tape, or tape B, also the blue ball. Each tape had a mass of about 0.002 kilograms, a length of 0.2 meters, and when held closely together, the charged tapes separated by a distance of 0.005 meters. Then in the glow script model, we also see some more information, such as the number of electrons lost on a piece of tape, the electric field, and the electric force at tape B. Here's the calculations made in Lab 1 as well. We can see here in this first left picture, we see Q is equal to 2.35 times 10 to the power of negative 9. That's just the charge for the point charge on each piece of tape. And then we'd see the number of electrons on each piece of tape, the total amount of atoms, and then we solved for the ratio of total atoms per electrons lost. And then here we see that number would be 2.72 times 10 to the power of 7 atoms per electron. Here we see Lab 2 calculations. These differ from the Lab 1 calculations because in Lab 1 we were focusing on a single point charge. Meanwhile, here in Lab 2 we're focusing on the entire charge along the length of the tape. So first we had to find the gravitational force on the tape. We found this by multiplying the mass of the tape times the gravitational acceleration. Then we set that equal to the electrical force of the tape, that ending up being 0.01962 newtons. And then this electrical force is also going to be equal to the charge along a rod, since we're acting as if the tape is a rod. And then adding in the rest of our variables, such as R being the separation length and then L being the tape's length, we find that Q is equal to 3.3 times 10 to the power of negative 8 coulombs. So for the glow script code, we had to commence by adding the starting conditions of this experiment. We added the mass of a piece of tape, the length, the separation between the tapes, and then the estimated net charge on one piece of tape, which was the point charge from last lab. We also had to create a function for the electric field. This was done in Lab 0, but here you can see that we just had to find the R vector, the magnitude, and then the unit vector of that in order to find the overall equation for the electric field. Now on the left here, we see a function. This function was already given to us in the template, but this is the function for a line charge, and this is very important since we're acting as if the tape is a rod, and we're having to measure the charge along the length of this tape. And on the right of the slide, we see the electric field calculations at each point along the tape. And then all this coding leads us to the final computational model created by glow script. The red line of different dots and charges represents the top piece of tape, and each of these individual charges has an electric field pointing upwards created by the bottom piece of tape kind of repelling each other. Then we also have the white big arrow that represents the overall electric force acting on tape A, the red tape, and then we have the downwards gravitational force obviously created by the gravitational pull of the Earth. Below, we also have results for the magnitude of the electric force and the magnitude of the gravitational force, basically just the values of the white and yellow arrows, respectively. So now as we finish up this lab report, we have to state both the assumptions and errors made throughout this experiment. We did have to assume that the charge on each piece of tape was evenly distributed and that both pieces of tape had the same exact charge. Some errors could have been found when handling the piece of tape that could have affected the charge on the tape, maybe taking away some of the electrons through our hand contact or contact with the table. And then we also could have had some simple errors in both the math and coding. I know the coding especially was hard for me on this lab, so there definitely could have been some errors. The first discussion question states, what would happen if we modeled each of our tapes as a single point charge? This is exactly what we did in Lab 1, so we just compare the point charge found in Lab 1 to the line charges found here in this lab. And these estimates differ because the line charge model uses a smaller and more precise intervals. Meanwhile, the point charge we used in Lab 1 is just one big, estimate of the entire charge spread out across the tape. So by using small different intervals that represent different parts of the tape, we get a more accurate reading.